Now, when you're building your computational model of the spring mass system, one of the things you need to know how to do is to express the spring force in vector form. And that's because the spring, and you'll see in not this lab necessarily, but the next lab, the spring can move in more than one dimension. So we have to express that spring force as forces are all vectors, and this is no exception. So the first thing we need to talk about is that in your code you have a term which describes the attachment point. That's spring.pos. That's where the spring is attached. And the other end of the spring is tied to the mass. So that would be at ball.pos. Ball represents the mass in the computational model. So from this we can define what we call the L vector, which points from the attachment point to the at the fixed attachment point to where the spring is attached to the mass. And I've wrote out for you the code which describes the definition of that L vector in terms of ball.pos and spring.pos. Next, we can define a unit vector, and now going forward, I'm not using Python or Python language. I'm just writing it in our usual expressions, symbolic form. You need to define a unit vector, which corresponds to this L vector. From that, you also need to know, as you know, to express the spring force, the amount the spring is stretched or scrunched compared to its relaxed length. So we need that quantity S, which is the difference between the magnitude of that spring force, or the spring, or that L vector, and the relaxed length. And then once you have that, you can write down what the expression is. Here's the vector expression, which is basically the magnitude is the spring constant times that deviation from the relaxed length. And then the direction vector is given by L hat, but minus, because it points opposite the direction of the L vector. That is, the force points from the ball to the attachment point when it's stretched beyond its natural length, and when it's compressed, then basically the sign changes, and you need the minus sign to get that direction correctly expressed.